data sets across the National Statistics offices. So there's a limited amount of data that we're looking at. So we're looking at the labour force data, the census data, and EU Silk data. And what you're going to see today are some of the tools that have been developed on this pipeline. Thank you. Okay.
Will you go back just one slide?
Mm-hmm.
Great. Okay, hi everyone. So I'm going to give a short introduction of the project, and the tools that we used and so on. But just first to mention that this presentation is available on SlideShare, so you can follow there as well, because it has all of the links to the different components and elements that we're talking about. So if you go to this URL, which is my SlideShare account, and that'll be disseminated later as well. Okay, thanks. Okay, so the pipeline itself, so the remit of the project was to make it easier for statisticians to publish linked open statistical data, but also to allow citizens to engage with and use the statistical data, linked statistical data. There's many benefits to linked data, from discoverability, interoperability, reusability, but anyone who's worked with linked data knows that it can be quite difficult really to get your head around the technology itself and the different kind of tools that are available to work with it. You have to be maybe a pro with RDF to understand triples and how it all works. So really, to get these benefits, we wanted to make it easier for people to publish and use linked open statistical data. So in a nutshell, the LOSD pipeline, the linked open statistical data pipeline, is a practical and complete LOSD pipeline for the publishing of statistical data on the semantic web. And when we say complete, we mean the entire pipeline from the publication, linking, usage, analysis, and visualization. So an end-to-end solution. Okay. All right, so linked data. In the context of this project and in general, we're referring to 5-star data. That means that it's available under an open license on the web. It's available in open machine readable formats. It uses URIs as identifiers, and it also links to other data sets. So this is what we're talking about with 5-star linked data. This is what we wanted to achieve with the pipeline. And like over the past 12 years and more, the availability of linked data is increasing steadily. So here we see this is the linked open data cloud, which represents the linked open data sets that are available. From 28 datasets in 2007 to over 1,200 datasets now. And this, of course, represents billions of triples, billions of links of data that's available, linked together, building a huge graph of knowledge that can be used and reused for data management. So for our project, the publishing architecture that we started off with was, first of all, we had the different data sources that we were working with. So in this project, we focused on statistical data, and we honed in on a certain formats that we could easily use within the pipeline. So that was JSON stat and also CSV. So they were the formats that we were using. Now, in the linked open statistical data space, we managed the mapping and the conversion of this raw statistical data into linked data. And then the other element of it was to make this data available via a number of different endpoints, APIs, so that it could be used in different applications. And that could be for analysis, visualization purposes, or for third-party applications itself. So that was kind of our architecture starting point. So then we carried out a review of how actually we were going to implement the pipeline, what technologies were we going to use. So we honed in on this set of tools, which we thought were best placed to carry out the work of the pipeline itself. So we used the CCAN front end. So CCAN is an open source data catalog for the data management, storage, and some of the conversion technologies. And we'll talk about each of these components in more detail and demonstrate how they work in a moment. We also use Juma and the Juma API, which was developed in the Adapt Center in Trinity for the mapping and conversion of statistical data to linked data. And for the visualization piece, we use OLAP Browser and Cube Visualizer. So they were kind of the tools. And in the back end, the Virtuoso Triple Store is where the RDF linked data is stored. Okay. Sorry, go back. It's a good one. Oh no, so. All right. So, as Owen mentioned, within this project, we're working with 4 different pilots because we wanted to create a pipeline that really demonstrated the value of the pipeline, something that actually worked in practice and worked for NSOs. So the 4 NSOs, National Statistic Organisations, that we work with in the project is the Central Statistics Office here in Ireland, ISTAT in Italy, INSEE in France, and the Bulgarian Statistical Office as well. So the 4 different pilots from 4 different countries. We also honed in on a certain number of data sets, again, that we could demonstrate the value of the project or of the pipeline. So the data sets that we use in the project are the HC55 census data, which covers population data from Nuts-Tree region, sex and age, the labour force data, the Survey on Income and Living Conditions data, the SILC data, and the International Labour Office unemployment rate data. So these are the 4 data sets that we worked with throughout the project. And just before we kind of jump into actually demonstrating the pipeline, I just wanted to say that, so Owen also mentioned that there was kind of 2 strands to this project. One is looking at the publication and usage of linked open statistical data, making that as easy as possible. But also really we wanted to not just create some tools and put it out there, but to make sure that they were usable by people. And that was to ensure that the capacity was there as well. So we have the LOSD training platform where we provide guidelines and user manuals for each of the components to allow people to take people step by step through the process of publishing linked open statistical data, but also the usage of it as well. So here's the URL, so you can log in. It's based on Moodle. That's extensible as well. Okay, so the way we're kind of going to talk through or demonstrate the pipeline is through the 3 use cases that we defined at the beginning of the project. Because again, we wanted it to be as practical as possible, something that was really useful for the stakeholders that were outlined in the project. So the first use case is for the NSO statisticians publishing linked open statistical data. Okay, so the different components that are involved in this. So this is for a statistician. It's based in a national statistical organization, and they want to publish some linked open statistical data. Where did it start? What did it do? What's involved? So first of all, we have the CCAN front end. So again, this is the data management piece, and then Joomla is used for the mapping and the conversion. So if we jump into maybe a demonstration of both of those tools, both CCAN and Joomla. Okay. And then we can walk through step by step how a statistician would actually publish linked open statistical data based on the pipeline. So we're going now to the CCAN platform. So if we just go to the home page first, click the icon top left. Top left. Sorry. Yep. So CCAN, a lot of people are familiar with CCAN from open data portals in general. It's commonly used because it's easy to browse around, easy to list all of the different data sets that are available, described using metadata and so on. So we thought it was a good point for people to be able to interact with easily, find the information that they need, and it's also extensible, which was very important for us in this project. So here on the home page you can see links to the data sets from each of the 4 NSOs, statistical organizations. So what we're going to do is add a data set and convert it to RDF, and just to show how easy it is. So if you go into the data set page, yeah, and click on add data set. So what we're going to do is add a CSV data set and a JSON stat. So if we put in a title, just hold that 1 second. There you go. Okay. Okay, so if we put in the title Silk, because we're going to use the Irish Silk dataset, underscore webinar. Okay, we're going to skip down through the metadata just for time. And if we go down, the visibility should be public, because it's an open dataset. Okay. And the other dataset, the other metadata fields, so it's CISO and so on. Okay, so there's lots of other metadata that we could add, but for now I'm just going to skip over them for the time being and add the actual data resources. So like I said, I have two different resources. So one is the CSV file. So
Can we go to desktop?
yeah, can you? Oh, actually,
Sorry.
here. Yeah. Desktop.
Okay, and then there is data robin here.
Okay. And this is the CSV one, right? Great. Okay. And so for name, we'll just put in IE CSV, so we know. And the format, we also put in CSV. Okay, so save and add another, because we're also going to add a JSON stat file. So if we go back to upload, now we're adding a JSON stat. So this is the same actual data set, added as, so here I'm just going to put in JSON stat, and go down to format, and again put down JSON stat. Okay, and I'm going to finish that. Is that okay? Can you jump in the location? Is that right?
Okay.
Okay, so now with the two data sets here, so we're going to convert first of all the CSV and then the JSON stat file. So the CSV file itself, if we click into it, so this means that both of these data sets are now available on the CCAN portal and they're discoverable. So we can convert this resource to RDF. So this is the section that we've added. So this ties into the JUMA mapping that Alan's going to talk about in the next session. So there's been a mapping that's been created from the CSV file into the RDF format as well. So we can put in our credentials here. So in this case, it's test user. The mapping ID, which Alan will explain, it identifies a certain mapping. And if we put in, so the title of the new resource, we just put in silk, IE, CSV to RDF. And that's it. It's as simple as that. And if we click on convert to RDF, okay, so now it's actually doing the conversion. So it's using the JUMA API to convert that CSV using the mapping. And here you can see on the dataset page, we've got a new file has been created, which is an RDF file. And if we click into it, you can see that it's actually an RDF file with all of the different statistical elements of it. So we don't have time really to go through each of these, the actual RDF files, but it's there as well. And as I said, Alan will talk about the mappings. So that's the CSV to RDF. The other element is the JSON stat to RDF. So this is done slightly different because the JSON stat already has statistical dimensions and elements within it. We can do the RDF conversion directly within CCAN. So again, you can see this section that has been added, the convert this data to RDF. So if we put in the ID, so here we have, we'll put in silk underscore IE underscore JSON to RDF, and we just have to put in the vocabulary and data space namespace. So we're going to use the same as the URL here. So this is just used for creating the RDF, and we can put in vocab here. Whoop. That says vocab, doesn't it? Yeah. My eyesight. And this one can be data. Okay, so once we have those elements defined, we can again click on convert to RDF, and this is going to do the conversion from JSON stat to RDF. So you can see here we got a notification that the RDF file is actually being created. So if we refresh the page, we should see an additional file that's available. And here we have the JSON stat to RDF file as well. So if we click into that and click in, we can see here's the actual RDF data itself. So that's as simple. If you're a data publisher, if you're a statistician, and you want to convert CSV or JSON stat statistical data to RDF. And then the final element is this piece here, this section. So once you have an RDF file, you want to make it available via the Virtuoso, the triple store, so that it's further available to Cube Visualizer, OLAP Browser, and other access points as well. So you can push the resource to the RDF store. So if you put in here the URL of the Virtuoso RDF store that you're working with and the other credentials, and push the RDF store. Again, for the purpose of the webinar, I'm not going to go through that piece, but it's as simple as that. It's really kind of putting in the credentials and elements within the CCAN, and it can publish there, and it's available according with the other linked data as well. Yep, so that's it. as you can see, kind of with CCAN, it kind of keeps it all together. We've made it as simple as possible, and we'll show now kind of how it's tied in with the other components as well. Thanks, Lucas.
Okay, so I was informed that there are some problems with streaming, so just to make sure that if you have any issues with the screen, we are recording the session, so it will be available later for you to see. Anyway, if you foresee any problems, just want to double check what's going on here. So it seems like it's going. So I think we should just proceed. I think if there is any issue, we will just provide a video after the session. And so we continue now with the presentation, and we have now here. Okay. So we are here right now, and we have CSV. That's what we covered. And now we have Joomla.
Okay, so I'm going to talk about the CSV to RDF conversion part, and this is done using a tool called Joomla. So what Joomla is, it's really a graphical user interface built on top of a W3C standard, which is called R2RML, which really stands for Relational Data to RDF Mapping Language. And so the idea is with R2RML is you create a mapping, and in that mapping you specify how you want to transform your CSV data and how you want to transform it into RDF and how it looks and how it's structured and things like that. So those mappings are normally natively written in RDF itself, and it'd be quite a difficult language then to manually create those mappings. So Joomla then provides an interface then to help with the actual creation of those types of mappings. So as Deirdre said, we have a JSON stat to RDF converter, and that's able to take advantage of all the context that's already within a JSON stat file. But normally within a CSV file we don't have that luxury. So actually creating the mappings that do the conversion is the approach that we take in the pipeline for CSV to RDF. So with Joomla, Joomla it's a GUI, of course, for creating the R2RML mappings, but it also allows you then to store mappings and allows you to save them and add descriptions and to also reuse them via an API. So what I'm going to show is a demo of Joomla, just a very quick demo of logging in, seeing the mapping repository page, how you create a new mapping, and then I'll go into an existing mapping, one for the conversion of Italian data ILO to RDF, and I'll execute that and kind of just show you the kind of the workings of Joomla itself. So,
okay, so
if you can go to the page.
Okay. You wanted to show the video first? So
No. So out to the platform.
Okay, just this one. Okay, Joomla editor.
Okay, so this here is the Joomla login page, so I'm going to log in. Okay, we don't want to save that. Okay, so this is kind of the Joomla home page for a user, and right here we have a number of mappings. So this is like a catalog of mappings that's already been created, and they have kind of titles and descriptions, and it's important that you give them a meaningful title and description so they make it easier to find. On the very left hand side then, each mapping then will have a unique ID, and as Deirdre mentioned in her presentation, it's that ID number that you will call upon to use the Joomla API for the conversion of the data. So down the bottom, we can create a new mapping if we wish. I'll just quickly show you. Click on Create Mapping.
and the new mapping then appears down the bottom. So clicking into it, we have this interface. So from here you can start to build up your mapping itself. So you can go into the different components, you drag and drop them in, and this is ultimately how you're going to build up your mapping. So just a note, so you will need a bit of practice in order to actually use Joomla, because there is still a kind of a learning curve in order for you to be able to, create these types of RDF mappings. Under this tab here is where we can select, where we specify our source data. So what you do is you provide a URL then to your actual CSV data file, and this should normally be from the CSV file, such as what Deirdre done in her demonstration, the URL for the CSV file on CCAN. And you can change the title and description then if you wish. So that's how you create a new mapping, and of course how you're ultimately going to build it up over time. So now just to show you an existing mapping, and again this is for the Italian ILO data. So within the source data here, we ultimately have a link to the Italian ILO CSV file that's hosted on CCAN currently. So this mapping itself has already been created, and there's kind of really three main parts to the mapping. The first part here has got to do with creating the schema part of the data cube model. The second part is got to do with the code list, so it's generating the code lists of the data cube, and then the final part is got to do with the actually generating the observations. So I know I'm skipping over those three main sections pretty quick, but they are in the documentation and are explained further. So the idea is, again, with Joomla, you're not just going to create all this in one go. Just like in a programming language, you should create it bit by bit, and you should test it out just to make sure that it's running and it's generating the correct RDF. So what you can do is you can, when you actually run the mapping, what will pop up is an RDF preview, and again that's really just so you can go through it on the screen just to ensure that your mapping itself is creating the correct RDF data. Okay, so see it pops up here, and you can have a look if you wish, and if everything is fine and you think you created the mapping correctly, you can then, if you wish, you can download the data as well if you want to have a better look. So you can save link as, and you can save the file to your desktop or whatever. But again, once you have your mapping created, kind of take note of the mapping ID, because again that's what you will really use for the Joomla API conversion, as what was shown in the CCAN instance. So in a later demonstration I am going to show basically how you can programmatically access the Joomla API, as well as programmatically be able to query the data within the RDF triple store.
Okay, so now we will switch to the video.
Nope.
Okay. Back to the presentation. And just double check whether anything coming in here. Okay. I'll just move on. Okay, so now we go back to the presentation. Okay. We have here. Okay, we want it further. Sorry, I'm missing something now.
You say still,
Yeah.
It's okay.
Sorry guys, I have a bit of a cold, so forgive my coughing. Okay, so that was about kind of use case one, about publishing linked open statistical data. So now we're looking at use case two, which is about facilitating general public users accessing linked open statistical data. Sorry, to make it as easy as possible to use. Okay. Drink. Okay, so the components that are involved in this is again CCAN and then the OLAP browser and Cube visualizer. And so if we jump back into the CCAN front end.
You want to just go here.
Okay. Okay. So previously I kind of skipped into a statistician who was familiar with the front end as well, could go straight in, add a data set and all that was involved in that. So now I want to take a little step back and look at the CCAN portal itself and what else. So if you're a user coming here to find LOSD or to maybe browse what's available. So first of all, on the homepage, like I said, we have kind of an overview of the different data sets that are available for each of the NSOs. And if we look at the dataset page itself, we can see an overview of all of the data sets that are here. So what CCAN does very well is make it easy to find information. So you can search via the different facets here on the left. So for example, if we want to just see what data sets are from the CSO, you can click on that facet and the data sets that are available are filtered down. You can also do a keyword search. So if we search in the keyword search here and put in, for example, silk, we can see all of the data sets that are here. For example, the data set that we created earlier on. Another element that's really important with the data is all of the metadata that's there. So that's something that we saw when we were adding the data set. So you can create rich metadata to give context to what the data is actually about. And that's standardized via DCAT as well, which is a W3C standard and adopted by the European Commission data portal and lots of other open data portals as well. And then just finally, that as a user, when you're coming in, so it's easy to find the information that you want, it's easy to kind of browse around, it's easy to find out about the data set through the metadata to give context. But also if you want to have a look at the data set itself and what it actually contains without having to dig in. So for example, JSON stat, it's a statistical format, so it might be a little bit tricky for somebody who's just looking at the raw data. So we wanted to provide some previews to make it just off the bat a little bit kind of easier to understand. So here, if you kind of see under, we have this, the convert the resource to RDF, like we talked about earlier on. But down below, we have a preview of the data set. So we have kind of a graphical representation, also tabular. And you can kind of play around with this as well. So if you want to change around maybe the rows and the columns, hit a statistic and so on, and that automatically changes the graph. So previews are really important just to give users a feel for what the data is about. And this is for lots of different formats. So if it's in CSV, there'll be a tabular preview. You can work with graphs as well. But with JSON stat, that you can look at different slices of the data. So straight away from the portal, it's easy to understand. So yeah, so that's kind of the point of the CCAN portal from for a user perspective, as a data manager, data storage, and also for the data conversion itself. But for more, I guess, detailed visualizations of the linked open statistical data, then we've provided separate tools for that, and that will turn back over to Luca Schnarre. Thanks.
Okay, so now we will move back to, so we will now show the other tools for visualization, and so I will switch shortly for the presentation again. Okay. So you have two tools, OLAP Browser and Cube Visualizer, that enable us to explore the linked open statistical data in a bit different way. So the first tool we're looking at will be the OLAP Browser, and I will open a live demo for you now, just right now. Okay. Okay, I have to move this one, sorry, this window here. Okay. Okay. Now, okay, you see the main window. So I will, for the purpose of this demo, I will use the data set from France on demographics, and this part is generated dynamically. So here we take the advantage of the OpenCube vocabulary, and we can select different dimensions. So for instance, we have row, age, and we can select, for instance, age by gender. And for instance, we have it now, values for country, entire country, year 2011. Let's see what's going to happen. So we have distribution of population in different age groups here. So we have year 15, 29, 30, 49, and we see how many males and females are in each group, and also the total. So we see that the total population of France is 64 million.9, and then we see that the total population of female is slightly larger than male, 33 million against 31 million. And then you can see also how it changes in different group ages. And what is interesting here that you can observe from straight away is that there is significantly more females in the age group above 85. So there is 1.14 million against just 400,000 males, and also this difference seems to be, so you can observe, for instance, from these two tables, from this one table into two rows, two columns, that this difference seems to be increasing, right? So for instance, in the group age 65 to 84, we have 5.2 million females and there's 4 million males. So this is one of the way of looking at it. And then, for instance, we can also select specific region in France. So for instance, we select FR1, and we see specific statistics for given region. Yeah, so you can explore how those differences, demographic differences, present themselves in different regions of France. And so this is the basic tool of Ola browser. So it's all about kind of tabular exploration of the OpenCube data. So dependable on the different dimensions available in your data sets, you can traverse different dimensions and apply different measures and filters. And now we would like to do a similar operation in another tool, which is the Cube Visualizer. So I will go back for the presentation for a short while, and we can see the same data presented in a slightly different way. Okay, so I will select exactly the same data set now, as you can observe, and we will do more or less the same. So we can say, for instance, age, gender here, total, and we have the bar chart now, but we can, for instance, let's do a pie chart, and we can observe now, for instance, the total distribution of population here by gender. So let's check, for instance. So we see that there is 33 million females. Now and you can actually sort it. So for instance, you can use pie chart sorted. Okay, so now you see exactly which groups are the most dominant, and you can see that the largest group is between the age 30 and 49. Yeah, so for instance, I can switch, let's say, to different dimension now, and you can see how we can observe that for male now, male population. So it's similar. You see that we have again the largest group represented is between 30 and 49. So this kind of sorted pie chart can give us a bit different overview and visual explanation for the demographics here, right? And this is again for entire country. So we see this pie chart for entire country, but we can select the different regions. So for instance, FR1 again, as we did in the other example. Yeah, and then we have the specific statistics for this region in France, and again it's sorted, so you can observe different groups, and you can see that among males, this tiny group here is male above 85. Yeah, so again, and we can check again for females, just for the comparison. So it's a bit more, you see here, and the same for the group age 65-84, and it's more visually expressed using this sorted pie chart here. So we look at the same data set using two different tools. So one is the Ola browser, another is Cube Visualizer, and you can see that. So first of all these parameters here on the left, and so the dimensions measures, these are fetched dynamically. So dependable on your data cube, you will have different measures and values, and you can select from. Yes, so that's the biggest advantage of those two editors, that they are adaptive to your specific data set. And I think we'll progress further now. So I will just move back to the presentation.
We're doing quite well on time.
Yeah. Okay. Okay.
Thanks very much. Okay, so we've covered two different use cases so far. The first is supporting the publication of linked open statistical data for statisticians. The second was facilitating the usage of linked open statistical data, making it as easy as possible for people to interact with and browse and explore the data. So now we're going to talk about our third use case. So it was also very important for us that the linked open statistical data was available for third-party use as well, because the whole point of linked data is that it's widely available and it can be integrated with information from different sources. So this was quite an important piece for the LOSD pipeline. So use case 3 is NSO collaboration with third-party partner for developing added value services. So that a third party can take the LOSD and maybe use it in their own application, integrate it with other data sources, analyze it, and so on. So the components, go to the next slide, please. The components that are involved in this is again the CCAN front end and JUMA, but also very important here for use case 3 are the different access points. Because while we wanted to make things very easy in this project, or easier than they would be maybe using traditional linked data tools, so the user interface, user-friendly, all of that is very important. But also we wanted to facilitate the machine accessibility of the information as well, and also the functionality. So all of the components that we have, the data is available via APIs and endpoints, but also the functionality of the different systems. So for CCAN, you can access the functionality via the CCAN API and the data stored there. The Virtuoso Triple Store, the RDF store, where all of the linked data is stored, is queryable via a Sparkle API, the Sparkle endpoint, and also JUMA. The functionality there, the mapping and the conversion, is accessible via the JUMA API. So in that way, an app developer can tag into the different components, access the data, and bring it into their own systems as well. Okay, so Alan's going to talk a little bit more about the access piece, and then we're going to give an example of using the access points, how a third-party application could be developed.
Sure. Yes, so the two main access points from a developer's point of view, well, there's three, of course, including CCAN API. The ones for actually accessing the raw data and the conversion and so on, if you will, is the Sparkle endpoint, and the other one then is the JUMA API. So I'm going to show a demo of these in just a moment, but of course the idea is behind the Sparkle endpoint is that you're able then to programmatically send Sparkle queries to it and retrieve data, and then for your application, and then you would parse that data and display it however you wish in your application. And the purpose of the JUMA API then is so you can then quickly call on the JUMA conversion process for quick conversion of your data. So that's very useful in cases where you would have a mapping that's already previously been created. Let's just say for again Silk data for 2018. So when it comes to the 2019 data and you want to convert that into RDF, assuming that the CSV structure of your data is still the same, you can just simply send the 2019 data now and do the conversion with JUMA, the JUMA API. So I'm going to show a video very quick right now. Okay, the video is here.
Sorry.
Sorry folks, just a moment.
Yeah, yeah. Or you prefer to show the live demo? So, is this? Mhm. Okay. On the screen. Okay. Let's show on the other screen now. Okay. No, it doesn't want to. It's not good. Okay, just give us a sec. I'll try to. Yeah, that should be this one now.
Oh. Need to restart that video.
Okay, so we are showing you the video and I will start it for you shortly. Okay. Yeah, should I cover it? Is it okay for cover? Okay.
Yeah, full screen.
Okay, so I'll just put it in full screen here. So it's going on, yeah. So you can see all the details. Okay, so you see the screen here, what's going on?
Mm-hmm. That's what's playing, is it? Okay, so I'm going to restart that video if I can.
Doesn't restart here.
Okay, right, so again, the idea of this is for mainly catered towards app developers, and what you're going to see here is two simple scripts that have been written. So hopefully this is visible to you. If it's not, please get in contact with me and I will certainly share this code with you. So what we have is we have two scripts here. One is it's really just concerned with sending a query then to the Sparkle endpoint. And it's this script that we have on screen right here. So what I have specified here is just the endpoint of this service. Below that then I have the actual Sparkle query that's going to be sent. And I've just written a very simple function in PHP to just send that Sparkle query to the endpoint via it's really is a RESTful kind of call that's made. So a simple HTTP request to the endpoint with the query attached. So and what's going to happen is I'm simply just going to echo then the results of this query out on the screen. So I'm just executing that script right here, and what you can see is here's the results then from that query. The results come back in JSON form, and what this query is doing is it's basically getting populations per quarter, per yearly quarter of the Italian ILO data. So again, that's JSON. As an app developer, you're going to know how to parse that and then display it then in your applications. So the other thing that I wanted to show then is the how to use the Joomla API programmatically. So for the Joomla API, as you may remember from Deirdre's presentation, what you do is, at least on the CCAN interface, you specify three things. This is the username of the mapping, then it's the ID of the mapping, and then your source data. So on the CCAN API, it knows what the source data is automatically, but for when you're using the Joomla API programmatically, you're going to specify basically the URI to that source data. And so again, what this script is also doing is it's simply just using, it's like a RESTful call, a simple HTTP call to the Joomla API with these things attached as tokens in the URI. So the username, the mapping ID, and the source data attached as tokens. So, and what's going to happen is, for the purpose of this, I'm simply just going to do the conversion and then echo the results out on screen. So while the results are going to be echoed out on the screen, of course, what you would do as an app developer is you would then, write that to your own file, or write it to, or you can manipulate that for, and even using then the CCAN API, you could then push that into CCAN. So that's how you do on-the-fly conversion of your CSV statistical data into RDF using JUMA mappings via the JUMA API.
Okay. Okay. So we have that now here. Just remove this window. And we go back to the presentation.
Okay. Click on that then, please.
Sorry, this one. Open new tab.
Okay, so we're coming towards the end now, folks, so thanks for sticking with us. Yeah, so what we wanted to kind of round up with is then to show how this data could be used. So here's an example of an application that Swaroop has developed. It's completely independent from the pipeline. So if we have the pipeline over here for the publication, the mappings, the conversion, all of that good stuff, but we wanted to be able to use it in an application that's completely unrelated to the pipeline. So this is an application that uses the unemployment rate data from 4 NSOs. So each of the 4 NSOs from Ireland, France, Italy and Bulgaria have published their unemployment data as CSV or JSON stat. It's been converted to RDF, and now we're using it to be able to query all of that information together and present it in a common way. So this is really kind of at the key of what linked data facilitates. So if we see here in the top left, we have just a simple map with 4 different countries colored in, and it's separated into different regions. So if we click, for example, on a French region, we can see the French unemployment rate data for that region. So that's FRF 32, and the average rate over the different categories per quarter and so on. Again, if we look at an Italian region, then it'll update to that as well. So for each of the qualification codes, we see the unemployment rate over time from 2004 to 2015. Here separated by quarter or by qualification code, and here's the different average amounts. Again, if we click on a region in Ireland, so we're sitting here in Galway, so we'll click on the local region here, and we'll see the trend here in Ireland has been very positive in that the unemployment rate has been steadily decreasing over from 2012 to 2018. And finally, if we look at a region in Bulgaria, we can see the rates of unemployment over time here as well. So what's really kind of nice about an application like this is it's interactive, all of the graphs automatically update, but all of the data. So here really what we're looking at is data coming from 4 different sources, but because it's expressed as linked data, we can easily join it together and present it in a common way. So that's an application like Alan was talking about. If an app developer was running a Sparkle query, accessing the code and presenting it in whatever way they want. It could be an application like this, a kind of a dashboard. It could be in a tool. It could be just as their own analysis or whatever. So I'd also kind of just like to point out at this stage some of our findings over the course of the project. Because here, if we see from this demonstration, there was actually a couple of, I guess, issues or barriers that we had around standardization. And this is more to do with the underlying data as well. And maybe Owen can talk a little bit to this as well. So like any kind of data analysis or data management, really the quality of what you can do with the data or the impact of what you can do really depends on the underlying data quality. Now, statistical data is very standardized as it is because of the European statistical system. But even at that, so for example, in this application, we can see that the NUTS regions that are used here in Ireland and France are NUTS 3, and with Italy and Bulgaria are NUTS 2. Is that correct? Right?
Yep.
Yeah. I confuse my NUTS 3 and NUTS 2. So straight away, we're not comparing exactly like with like because the size of the regions are slightly different. Another element that we've noticed when we're clicking around, so here, so this is a Bulgarian region, and we're talking about a timeline from 2004 to 18, whereas in France it's earlier data it's available. In Ireland we have from 2012. So again, the time ranges are slightly different. Now that's only a data availability, and we can look into kind of making sure that all of that is available as well. And then just kind of one final, I guess, differentiator between the different data sets we found is in 3 of the NSOs, 3 of the countries, the unemployment rate data is available via quarter, so the 4 quarters, whereas in Italy, the data is made available by qualification code. So this is something, again, in the semantics of how the data is collected, what does this qualification code mean, and when we're bringing it together, how do we compare it? Again, not exactly like, but like. So they're just kind of different elements that when we're looking at integrating data from different sources, the things that we kind of have to look at. But overall, I mean that, first of all, that it's available as linked data is a huge step towards the interoperability of the underlying information itself. Okay.
I think the other thing that we did notice was that the French data was seasonally adjusted, whereas the Italian, Bulgarian, and Irish data was unadjusted data. So from a statistical indicator point of view, they're different as well.
Okay, move back.
Sorry, this one.
Okay, so just to round off, so that was the presentation of the pipeline. We wanted to make it, as we said at the beginning, a very practical and a complete method of publishing linked open statistical data. And we tried to make it practical by really focusing on these 3 use cases: the data publication for NSOs, the data usage by general users, and then the third-party accessibility of the information as well. So all of the components are openly available. You can access them via the URLs. We'll have more information around them as well. And obviously kind of please get in touch if you have any kind of feedback. And also because we want to kind of build on this project as well and improve the overall pipeline. The NSOs from the different 4 pilot countries have been busily using the pipeline, giving us lots of feedback, so that's brilliant, so that we're kind of improving as we go along. But we would also encourage all of you who watch this webinar to go have a look at the tools, have a try, and please complete the assessment form as well, so that we can make it bigger and better in the future.
Okay, so just to finish up now, so as Deidre mentioned, we have the pilot assessment form, and we're looking forward for your feedback, and we're looking forward especially for for your opinions. So quantitative answers are important, but we look forward to your opinions. So if you can elaborate a bit, more specifically on the strong sides, on the challenges, and so on, that would be much appreciated. And just to sum up the webinar itself, so we are aware that there were some technical issues as we went through. So this webinar we uploaded immediately as a full video, and we will disseminate it to all registered participants, and also put it on Facebook and YouTube for you to follow. So that would be immediately after. Also, we will upload a video for the demo to make sure that you can follow that as well. And we are looking forward to getting your feedback. And there's nothing left. Thank you to all the participants. So do you have any questions registered there so far? No? Oh, any questions?
No questions.
Okay. So if there are no any questions, I encourage you to comment on Facebook and also to send us feedback directly, especially through the assessment form. And thank you for watching us, and we hope to stay in touch. And of course, please feel free to contact any of our members here. So Deidre,
Yeah, no, I think, I mean, it has been an amazing experience over the last year and a half getting this project together. And I think ultimately what we do want is that people will use the tool kit and then come back to us with feedback. And the advantage of the access of the data through the API fundamentally means that in the future, a National Statistics Office, once they publish the data once, when the next quarter data comes on or the next year data comes on, that it's automatically generated without the statistician having to do something on it. And the same if an app developer develops the app outside, that, again, because it's sitting on top of the data, that when the data changes, the app still functions perfectly. So I think that's really great.
Great. Any last comments from any other presenters? No. So thank you very much. Thank you for watching us. And yeah, again, please stay in touch. And yeah, I'll be sending the link to all the participants right away. So stay tuned. Thank you very much. Cheers.
Thank you.
Thank you very much.